So mechanical engineering, that's what we're all here for. What sets our program apart? So all of this information can be found on our website, and at the end of this presentation, there's lots of links if you really want to read in depth. But essentially, our goal at the U of R is to prepare well-trained, creative, and responsible engineers. And we do that in a few different ways. One, we have broad hands-on laboratory opportunities. So the majority of our students are working in labs or doing advanced design projects. So your senior year, there's the ME204 and ME205 series. So that's like a custom project. Students get into groups. They spend the entire year working on it. A lot of those projects are community-based. So it's lots of applications. So you will be in labs, like in machine shops and other things, getting that hands-on experience. A strong focus on analysis, design, and development of mechanical and thermal systems. So the actual theoretical knowledge you need. Our curriculum also includes some courses that are just designed to grow you as a leader. So we have a writing workshop that our upperclassmen take. It's called Communicating Your Professional Identity. So we try to prepare our engineers to be engineers and professionals who can work well in their field with others. A deep understanding of the broad social and economic impacts of engineering. So that's, I did mention earlier, there's some community-based engineering opportunities. We have a few different classes where our engineers get out into the city and work on different projects, and other the Rochester Center for Community Leadership helps with a lot of those programs. So there's a lot of opportunities to actually apply what you're learning and work with real people. And then of course, undergraduate research and study abroad, which a lot of students think that if they come into an engineering program, whether that be at U of R or at any school, there's not going to be enough flexibility in their curriculum for study abroad or outside opportunities, but a fair amount of our students do study abroad every semester if things are, back to normal in the world. But we have a handful of kids every single year studying abroad, and a lot of our students take on significant research position in labs, so they can fit all of those things in as well as whatever they're doing for the curriculum. So our department offers a few different majors and minors. We have 2 ABET accredited majors, one in mechanical engineering and geomechanics. ABET is the advisory board of engineers. Essentially, it's a distinction, a professional distinction, sort of like a certification that just says our program at the University of Rochester adheres to certain professional standards that are imposed by ABET. We have a variety of minors, fluid dynamics and thermal sciences, fluid and solid mechanics, structural analysis, materials and solids, and mechanical design. So if you decide you're interested in mechanical engineering, but don't necessarily, maybe you decide another engineering is what you want to major in, we still have a fair amount of minors. And then we have grad school opportunities, PhD programs, and then the Take 5 Scholars program, which some of you may have heard of if you've been attending admissions events. That is the additional year of study where you study another subject. And the mechanical engineering accommodates that program. So what does majoring in mechanical engineering actually look like? It's 128 credits of starting with foundational courses. So these are your math, chemistry, physics. You spend, a little bit of your first years trying to get those foundational courses going so you can get into your upper level ME coursework and succeed, at which point you get to the mechanical engineering core courses. There's 16 of them total. They range from fluid dynamics to thermodynamics the whole way up. Then we have some electives too, because we'd like to think of our engineers as more well-rounded, not just sitting in math, science, and physics class and engineering classes for your entire 4 years. We have a technical elective, so that's like a hands-on sort of, we want you to get out into a workshop. A lot of people take, the example here is precision manufacturing or optical manufacturing. So a lot of lab-based technical application-based courses. There's dozens of eligible ones. They're all listed on our website. So this is really an opportunity for you to pursue something you're interested in. The natural science elective is truly just because we want our engineers to get out into natural science, the true sciences, like astronomy, biology, geology is another popular one that students pick. So this is just really getting into a classic natural science course, not just math, not just physics, but really getting into just natural sciences. A humanities or social science cluster. So the University of Rochester uses a cluster system, which is essentially instead of the general ed requirements a lot of schools have, you're asked to take 3 courses in the other So if you're an engineer, you're in the Hagem School or the Natural Sciences School. So then we have the humanities and the social sciences. So those are the three divisions. You're essentially just asked to take 3 courses outside your division. As an engineer, you'll have to take 4, 3 that constitute a cluster. So that could be in the social sciences. A cluster is just 3 courses that sort of have some type of interweaving topic or something that makes sense. I was a U of R student myself. My cluster was in political science. I took like political philosophy and 2 other philosophy courses. So I sort of got like a little picture of 18th century philosophy. You know, it was intense. I would have never have taken classes like that otherwise. So it's interesting to see sort of where you'll end up in the cluster system. And then just 2 classes of your choice are built in. You need 128 credits, like minimum, to graduate from the U of R, and all of the required coursework for ME will only get you to 120. So there's just 2 courses that you can just pick from anywhere or anything. And then of course, like the Writing 273 course I mentioned earlier, and Writing 105, which is the Intro to Collegiate Writing course that every student at the U of R takes. There are so many selections. I think last year they had over 40 different selections of like topics you can write about. So the Writing 105 course is like standard sort of curriculum, but everyone's writing about something different in these courses. So I know some of them range from like, I saw one a few years ago that was like Princess in the Castle, analyzing feminism in video games, Ghosts in American Society. I took bioethics because it was the only one that still had space in it. So it ranges from bioethics the whole way up to feminism in video games. So if you're daunted by the idea that you're going to have to take a writing class, just know you'll probably be interested in what you're writing about, if nothing else. And then we do have some honors tracks. We have honors tracks in math, physics, and chemistry for students who feel particularly strong in those subjects. So the typical first year schedule, what you would be taking: math, chemistry, writing, and then math, physics in your first ME course. So in your first year, it's a lot of introductory type courses. Most of our students do take the same schedule with a little bit of flexibility. So when you're, looking at different schools and wondering, I know that was a question I had when I was applying, like, what do you actually take? It's one thing to say, like, I want to major in mechanical engineering, but like, what does that mean? What are the courses? So this is actually the schedule you would be pursuing your first year at the U of R if you were to come in for mechanical engineering. And then a lot of our students do also participate in extracurriculars outside. So the university itself has over 250 clubs, as well as sororities and fraternities. Some popular clubs that engineers get involved in is the American Society of Mechanical Engineers, Society of Women Engineers, Engineers Without Borders. So a lot of like more professional organizations and professional societies. Then we do have Solar Splash and Baja. So that's building solar powered boats, and Baja is like vehicles. So more hands-on, not just, the academic society. We have our robotics teams. And then honestly, I would say the majority of our students are heavily involved in some type of research or teaching assistantships. So either doing paid or unpaid research, or working with the department as teaching assistants, assisting undergrads, doing tutoring, hosting workshops, things like that. So one thing that I think makes our program a little bit different from a lot of other schools is how intense our advising model is. So if you were to come to the University of Rochester, you would effectively have 4 advisors from the time you start. You would have your undergraduate coordinator, that's me. I'll work you for 4 years and send you emails about like workshops you should go to. You'll have a faculty advisor. So that's actually a mechanical engineering professor who will meet with you one-on-one every semester to talk more about your career goals and your aspirations. So I myself am not a mechanical engineer. So as much as I'm an expert at what we're doing with our curriculum and policies for the school, I don't know a lot about the mechanical engineering industry. So we have our real mechanical engineering professors helping out on that side. You have a peer advisor. So that is an upperclassman ME student who's taken the courses. Again, I'm not a mechanical engineer. I didn't take thermodynamics. So when I have students come to me and they say, can I take these 3 courses in one semester? Will it be too hard? I'm not totally sure. So that's where the peer advisors come in. They've taken all the courses. They sort of know a lot more about the on the ground experience of being an ME. And they host hours. They work pretty close with me just to, get everybody squared away. And then you'll also have a generalized advisor that's familiar with all the different majors and minors at the U of R. So if you were to decide that maybe ME is not your thing and you want to switch, they'd be the first person you can go to talk about what your other options are, what the process is. So you've got 3 people specifically with ME and then 1 generalized advisor. And we start hounding you from like before you're even enrolled. Like you'll start getting emails from me if you end up enrolling in the spring, like already. Like I think that our advising model is phenomenal. Just as a U of R student and also looking at other programs I've seen, like you really will know all of these people personally by name, like not just someone you get emails from, but like you'll know these people. You'll go to their offices, you'll sit and have like peppermint candies with me, hopefully. So it's nice. It's like more of a community feel of an advising model, not just like we're pushing engineers out through the same like, 4-year sets of classes. So these are our first year advisors this year. They change every year, but there's Professor Niaz, Pakel, and John Lambropoulos. They all do their own different types of research, especially Professor Pakel they all do really crazy research. See, I don't know a lot about mechanical engineering. So I try to talk about like the kind of research. That's why we have Ethan. He can talk about research, but you can go online and see who our advisors are and what kind of stuff they're doing. Professor Pakel has a lab, so there's a lot going on that these professors are doing outside of just advising. So common questions that I get from incoming students and also students who are considering applying typically is whether or not you can receive credit for AP and IB coursework. Absolutely. If you were to be accepted, you would have to send your scores through admissions and they're evaluated that way. But we do have students come in with a fair amount of credit for their foundational courses. So if when I was going through the curriculum, you were like, oh my God, I don't want to have to take calculus again. I just took AP calculus. More often than not, those scores will transfer over. How do you contact your advisors? This more for students who are already accepted. You don't need an engineering laptop to come to the U of R. We have computer labs, so if you do decide to come here, you don't necessarily need to think you need to buy a ridiculous computer. Studying abroad, absolutely an opportunity. I said earlier, we have, I would say about 10 to 15 students a year studying abroad. If you are interested in studying abroad, it's something that you should talk to your advisors about early on. So not necessarily your first year, but your sophomore year. So we can start building your curriculum around that opportunity. And then that's sort of the same thing for double majoring and minoring. We do have a fair amount of students who pick up double majors. Some of them are double BS. So we have mechanical engineers who are also getting their degree in physics. That is a popular crossover. Or minors in physics or other HAGM departments. And then of course, we do have some mechanical engineers who are getting ASL, American Sign Language minors. So it's really up to you and your interests. There's enough flexibility in our curriculum to accommodate extra majors or double majors and minors. It's just, again, something that if you're interested in, definitely start talking to me and your other advisors to kind of see what we could do over the 4 years that you're here. So links to supporting information, of which there are many. You can go on the University of Rochester's mechanical engineering website and you'll find on there all about our program mission, our faculty and staff directory. So if you want to see what sort of research is being done, more information on curriculum and course planning is there. The CCC, or the Campus Community Connection, is a U of R website that shows all of our clubs and organizations. The e-board or the executive board of those clubs keep updates on the page. So if you're just sort of curious to see what sort of clubs we are, you want to learn about juggling club, go on there. There's all 250 plus, they're all listed. The U of R Center for Education Abroad website. So if you want to learn more about what type of specific study abroad programs we have, the study abroad Madrid is particularly popular amongst engineers. So if you want to learn about studying abroad in Spain, that's one good option. And then the Take 5 Scholars program, which I briefly mentioned, is an additional year of study in a different subject that a few students take advantage of every year. So it's essentially just an extra year of schooling. You don't pay. So it's really for the Renaissance Scholar sort of idea where you're just there to continue to take advantage of academic opportunities and to learn. So if you are interested in contacting me, there's my email. Our department chair, you could also email him if you're interested. He will not be joining us today, but he's the master of ME ultimately. And then of course we have Ethan and myself will be here for the remainder of our time today to just answer any questions. I think some questions popped up. Okay, so here's just a quick few questions about some of the information I covered. Can AP courses fulfill the first year of calc or physics requirements? Yes. Of course, it depends on your scores. So you need to be getting at least 4 or 5s, or particular, if you're doing IB, like the similar system, you can find the information on our university website. But there are students who test out of all, like most physics requirements and most of their introductory math requirements. Here's a good question. Can you describe the mix of theory and hands-on learning in the curriculum? Ethan, I feel like that is.
Yeah, that's right up my alley.
Yeah.
So just to give everybody kind of a little bit of an intro to me or introduction, I'm Professor Burnham. I actually was an undergrad as well, just like Sarah at U of R. So I started 14 years ago and I did my undergraduate work at U of R. So I went through the whole program. If you do come here, you will go through, so I can speak to that from firsthand basis. I also did all my graduate work here as well. So I completed my PhD. I taught full-time for the past 2.5 years. So I was teaching 4 to 5 classes. So the current classes have seen me quite a bit. Now I'm working at the laboratory for laser energetics a little bit more, which if you haven't heard is an associated laboratory where we do laser fusion research. And I work there in kind of an analyst capacity. But so to answer the question as to the mix between kind of hands-on and classroom stuff, it's a really good question. And I think the main thing I say about U of R is that we have 2 kind of capstone courses, the ME 241 and ME 242. Those are fluids lab and solids lab. And really what that is that in junior year, you will have had a huge kind of background knowledge in the main kind of denominations in mechanical engineering at U of R are solid mechanics and fluid mechanics. Are you going to deal with solids or fluids? And we have 1 course devoted to each. And in those courses, you will form small groups, propose a research topic, conduct active research on your own with your group under supervision. And then you'll come out with kind of a paper that you write up to kind of a peer-reviewed journal level. And so that's kind of the main hands-on courses I can point to. Just from having gone through and instructed many of the courses, we try and bring hands-on into almost every single course we teach. So for example, sophomore year, you will take a solid mechanics course that I taught up until this past spring. And in that course, we do 2 labs. One is a material testing. So we take actual samples of metals and we pull them with a giant machine until they physically break. And then we do a smaller one that is strain gauge testing. But basically in most of the courses, there's some type of hands-on portion. And then there's, of course, those lab courses where you'll do active research. And then senior year, you will take 2 senior design courses, one of which is a little bit more kind of computational in terms of modeling and things like that. But there's always a project involved with it. So you will computationally kind of model and use computer-aided tools to model a bridge or a cantilevered structure or a tower or something like that. And then usually what happens is that you then are asked to build those out of something like balsa wood that's really kind of brittle or will break easily. And we then have you actually load them physically in kind of a testing day, we call it. But everybody kind of gets together as the senior class and professors come and we all see everybody break those structures and things. And then the other portion of senior designs that you actually, again, similar to kind of the other lab courses where you have a project that you have to build physically. And so some of the most common or high profile ones, I guess I would say in the past few years are things for libraries. So there was a library project where it was kind of a Rube Goldberg machine that just moved balls around essentially, but it was to be set up in one of the local libraries. For the past few years, we've competed in the human powered vehicle competition, which is basically a bicycle, but how fast and streamlined can you make it? And the group actually builds this vehicle themselves. They then go to the competition and they actually compete in this competition, which is pretty neat. This year, there's talk of doing the human-powered submarine project, which would be a human-powered, like pedal-powered submarine that would be underwater. You obviously would need scuba experience for that. But there's a huge slew of hands-on things that go on in all of these courses that we try and bring into the kind of curriculum. As Sarah mentioned too, there's some really popular clubs are Baja and the Solar Splash. I'm the advisor for Solar Splash, where we build stuff. And so a lot of times, sometimes at the beginning of your kind of curriculum, as you saw from what Sarah put up on the slides, is that it can be a little bit boring the first year or two, which is kind of you're taking calculus, chemistry, and you are taking mechanical engineering courses, but you're not kind of taking all 4 courses are going to be mechanical engineering, like it might be junior or towards the end of sophomore year. And so you're maybe getting involved with those courses is a common tactic for students to get a little bit more involved and to meet some kind of upperclassmen friends who can kind of help you see which courses to take and can give you the lowdown on what to expect and things like that. Hopefully that answers that. I think there was another question that was how to major in ME, how to switch to and from. So usually the most common path forward for the first year engineers at U of R in general is, I believe it's your writing course, chemistry, math, and then what we call the EAS courses, engineering and sciences courses. Every department has one of these kind of intro courses, if you want to call it that. So ours is EAS 104, and it's bridges is what it's commonly referred to, but it's a nice smattering of kind of an overview of everything you will see in mechanical engineering in very kind of discrete forms. So you'll learn a little bit about a class you would take in the spring, a little bit about a class you would take in a year, a little bit about the computer programs you may use senior year to do some analysis work, but it's all presented in a very accessible way that brings it all together so you get a very good idea of what mechanical engineering really is. There are similar courses for biomedical and optics and chemical and electrical engineering. All of the courses have that. And so what usually happens is that if you take that course and you realize I hate mechanical engineering, that course can then be counted as kind of a technical elective is it technical, Sarah?
Mm-hmm.
Yeah.
So it depends on the department. Yeah.
Yeah. So that course can count, even if it's the Mechie course and you decide you want to do BME, for example, biomedical, the course you take in the mechanical engineering kind of intro course can count as some type of elective or science requirement for that major. And so it's supposed to be set up so it's pretty easy to jump between the majors, at least for the first kind of year or two. Mechanical engineering in particular is also really good. And I guess this is not as important for you guys because you've expressed interest in mechanical engineering, but we offer summer courses that basically cover the first 2 years worth of mechanical engineering specific courses. So you can always, if you miss a course or realize you kind of left Mechie but want to come back, you can usually pick up those courses in a summer kind of session if you want to jump right back in and kind of get ahead.
Yeah. And one of I get this question a lot from students is if you want to change your major, if you have to like reapply or apply specifically to that major program. When you're accepted to the U of R, you're accepted into all like the entirety of the U of R. So if you decide halfway through your first semester, mechanical engineering is so not for me, get me out of here, it's as simple as filling out a form. One online form, boom, boom, boom. I get a little email that says the student is switching out. I talk to your new advisor, and it's as simple as that. And again, with those HAGEM courses, electrical engineering, BME, almost all of those students are in those foundational courses their first semester, the math, the physics. So within the first year, there's a lot of switching going on. I get the switching emails all the time, people switching in, people switching out, people switching back. So don't think that you get, getting accepted as a mechanical engineer means that you're locked and loaded for 4 years. You have a lot of flexibility with the U of R curriculum.
I'm meeting with the student Friday, an advisee who wants to move from mechanical engineering into optics as a major, but keep a mechanical engineering minor. And so that's like, it's coming up all the time. So we deal with this constantly. And so it's not ever unheard of, and it's usually pretty easy.
Yeah. So what else do we have? Oh, can we talk about internship and co-op opportunities?
Yeah, so a lot of students do internships and co-ops. We actually have a course, Writing 297, that's entirely about building up your resume and interview skills. And so that's a big help to people and getting prepared for that. We have a career center that can help hook you up with positions that we know that are available from alumni. Alumni will post availabilities. When I was an undergrad, I actually did a co-op at the laser lab where I'm currently working now. as a mechanical design engineer, or mechanical design co-op was the technical term. But really, there's a lot of opportunities there. It can be, I know I've had friends who in undergraduate went all the way to California from Rochester and worked in internships at Lockheed Martin. I've had people who went to Boston, who moved home and found companies around there. There's lots of opportunities within Rochester as well. There's many companies that we know locally who are looking for mechanical engineers or people who have, they kind of know what to expect from a mechanical engineer coming out of U of R. And so they're more than happy to do that. And so there's many, many opportunities for that. Usually the main limiting case in internships is really what strikes your interest. And so whether you're interested in, as I mentioned, fluids or solids, or if you really are interested in space, that may tie you to trying to look at SpaceX as a place to do an internship or co-op. We don't have requirements on co-ops or internships, which some other schools do. So we don't say that like you have to spend a semester working as a co-op. Usually those are done either during the summer or part-time in Rochester. So I worked part-time. I put in, students are limited to 20 hours a week. So I put in kind of 10 to 20 hours a week working on mechanical designs in an applied setting while I was a student, extra pocket money and stuff like that. But it also was very, very good experience. So I highly recommend those regardless of where you go. But it's kind of on a case-by-case basis here. And your advisors are there to really help you, connect you to the resources there that can help you find and then get one of those co-ops or internships.
Which is honestly a lot of, I send out an email on a weekly or bi-weekly basis with internship opportunities. I get phone calls all the time. Essentially, it's just like people from Lockheed Martin that are like, we're looking for 5 interns and we like the University of Rochester students. They've worked for us in the past. Please give us some people. So you'll constantly be getting like peppered by me essentially with internship opportunities and whatever else comes across my table. And if I don't get any sent to me, I start seeking them out on my own time because I feel like a weekly update email without an internship opportunity isn't worth it. So I just start digging into whatever I can find on job posting, internet sites too. So you'll have plenty. And then of course there's word of mouth. Like I did 2 internships when I was a U of R student. I just saw a poster. Like I was just walking through campus and saw a poster, went to an info session, and then worked for this company for 2 years. So I think it's sort of odd how people end up with the jobs or internships that they have, but a lot of students do end up taking advantage of those opportunities. Okay, let's pick another one. Another question. What are some topics people have done their research papers on? That's a very broad question, Ethan.
Yes. So I'm going to assume this is related to the lab courses. And so just a smattering of ones that I remember off the top of my head. For the fluids lab, I did mine on reducing drag for shipping. And so we actually took on a small scale, the large scale idea is that if you blow bubbles underneath like an oil tanker's hull, it reduces the drag on the hull, essentially the friction between the fluid and the hull, meaning that you get better gas mileage essentially for those tankers. And even if it's a 5 or 10% increase, they use so much fuel that's a really, really large savings. And so we looked at a small scale test of that, and we actually used Alka-Seltzer coated spheres that we dropped through a fluid tank to see how quickly they would fall. So we dropped the spheres in without any coating, and then we like kind of glued on this Alka-Seltzer that would react with the water. And when we dropped it, we could see how it would fizz, and we got that, and it would actually fell faster. Other fluids lab kind of topics have been things like looking at the best type of kayak paddle to use. So what's the best shape that will cause that will give you the least drag when you're paddling, but with the highest kind of thrust that you can get out. We have a wind tunnel that we can use for experimentation. And so there's been a lot of projects with that. We've started to utilize 3D printing a lot. So 3D printing different inclination angles of wings. So wings sticking out this way versus straight out versus tilted back. And what's the kind of the aerodynamics there that arise from that. And we could 3D print little models of that and then actually test them in this wind tunnel. We've also looked at things like solar power or wind power. So for solar power, or wind power rather, I'm sorry, we were looking at applications in Africa. And so 50-gallon oil drums are very common. So if you take a 50-gallon oil drum, cut it down the middle and offset those halves, you can form a crude turbine, basically, if you put it on a shaft that it can spin kind of vertically around that axis. And we were looking at how you can put those together to harness the most energy. So we looked at not just a single one, but banks of them. So do you put them in a triangle like you see ducks fly, or do you put them in a straight line across, a straight line along? With the wind pattern, we were looking at the best ways to generate power for rural areas, I guess. Things like that. There's also been things like looking at using non-Newtonian fluids as a type of ballistics kind of protection. Non-Newtonian fluids, if you move slowly through it, it's a liquid. If you hit it fastly with a lot of force, it's solid. And so we were looking at kind of like BB guns shooting at it to see if they could be some type of, instead of Kevlar, you could use a layer of kind of a cornstarch goo as a vest that would protect you from shrapnel or something. Looking at the flow of sand as a fluid, things like that. If you flow air through sand, it can behave like a liquid. For solids projects, there's been a lot of looking at unique applications for specific materials. And by things like that, I mean like looking at the strength of teeth, kind of a biomedical tilt, but looking at how stiff and strong teeth are and that material is. Looking at the stress distribution. So if you're pulling on a material and there's a hole in it, how is that different from pulling on the material when it's solid? There's theories behind it, but can we verify those theories in practice? Looking at 3D printed strength of material. So if you 3D print something that's plastic versus just pouring a mold full of plastic of the same object, do they have the same strength? Do they have different strength? Are there parameters you can tweak in the 3D printing to make it stronger? Those are kind of at least examples of that type of project that you would look at. The only limitation thereof is the price and cost. So you're not going to be able to buy unobtainium and test that or something like that, or diamonds. And the time kind of constraint is that you have to work through it within a semester. So you don't have an unlimited time to work on this. So we try and advise you on topics that are doable as well as achievable within the time frame. On that note as well, usually all the past projects for the past like 2 to 3 years are always posted when you start the class, so that if there are projects that are a little more open-ended that could deserve some more research, you can actually continue on a project that's a little bit more established. You can propose your own, or you can kind of take ideas from some projects and some others and then mix them together into your own. And that's kind of just a lot. It's a very broad topic, but that's purposely why we do it. And that's why I think it's so exciting, is that we don't say you have to look at bone density or bone strength. You can pick whatever materials you want to look at, or different structures, or things like that. So that's on the research topics. And hopefully that gives everybody a good idea there.
And then we do have an undergraduate research fair every single year. It's typically in the spring, but students who are doing like really exciting research, whether that be like through their courses or maybe just other stuff they're doing, or even independent research, professors will nominate them to present at the undergraduate research fair. And essentially it's just a giant symposium where our like brightest undergrads make beautiful research posters and talk about what they're doing, and everybody comes and claps. I got to go my 1 year to write on some literature. I felt like such a scholar. Like, and you go to the U of R, obviously the U of R is a nice school and you're like studying hard as an academic, but there's one thing to just be like, sitting at your computer and like type every day. And then to actually have like world-class professors coming up to you and asking you questions about your research, your ideas, is insane. So that happens every single year, and there's kids there every single year. So depending on what you're doing, like that's absolutely an opportunity. You're a place you might end up to. We have a variety of different research journals that are organized by different departments. So I have some friends who've been published. Their undergraduate papers and research were published in different journals. So not only will you be doing this research for class, but it might really go somewhere in a professional way, especially if you're considering master's degrees or PhDs. So those research opportunities are big. They're big stepping stones for a career, especially if you're getting into theory. So there's a lot of wiggle room in what you're doing and where those projects can go. And I think this kind of segues nicely into a question about maker spaces and type things we have. I know there's a lot. You mentioned the wind tunnel. I know yep. Retner. We have the Retner fabrication building. It's an entire building dedicated. It's just different studios from the first floor to the top.
There is a full machine shop that's student accessible in there. You can take a course in how to learn to use a lathe and a mill, all all the way to just hand saws and things like that. That's a very popular course. They have 3D printers available. You can print on your own. You can also print for classes. We have large, like 6 foot by 8 foot or 8 foot by 8 foot CNC cutters for plywood. So we always you can make like giant gears and things like that out of plywood or wood to mock up for different projects, things like that. It's generally open, and there's kind of oscilloscopes and various pieces of equipment, so you can go around and play with stuff. There's also as we mentioned, the wind tunnel. There's also the Baja shop and the Solar Splash shop. And so those are spaces where you work on the kind of projects, but there's always kind of some side projects going on as well. For example, the Baja students at one point built a grill in their spare time while they were in the shop with their plasma torches and welding and everything like that. So they can have cookouts outside when they're working on Saturdays, so they can grill up burgers and dogs, which is kind of neat. The department has some space for working on kind of like hands-on type of things. Those are generally reserved for classes though, so they're a little bit less used kind of on a student by student basis. But as well, if you are involved with kind of research with a professor, there's a whole other host of opportunities and spaces that are available. But in general, the campus has kind of a lot of spaces available for maker type stuff and things like that.
And they do also they have like workshops sometimes, like for like, let's say you switch majors, but you still really want to like get into the wood shop. A lot of clubs on campus and things will open those spaces up for like small projects and things. So if you end up switching majors, but like still you just want to get in there and build a guitar. I had a friend who did that. They talked to like who runs like Retner in those spaces, like proved their competency with the machines, and then they just made a guitar because they wanted to. So don't think that the only shot you have to get into these spaces is to be an engineer. If you end up switching, these spaces will still be available to you as they are to the majority of the student body. So we also have a question on how has teaching mechanical engineering changed in the age of remote learning, especially for the hands-on? That's a toughie. Look at them. That's a big toughie.
So we've done a lot of work. So as with everybody, we were kind of thrown to the a curveball in the spring right after March when we transitioned to online teaching due to everything. And so I'll tell from first experience in my class, instead of having everybody conduct the lab, we actually recorded myself and the other professor who was teaching with me doing the actual lab once. And then we gave everybody unique data sets. So we took like 50 sets of data and gave everybody their own data set for the lab, like what you would get if you were doing it on your own. That doesn't mean you could conduct it. We've spent the whole summer and this fall, we meet regularly as faculty. We have representatives in groups that are talking about senior design projects, lab-based courses about how to transition for exactly what this question asks. And I think we're doing a relatively good job. We've been trying to do little hands-on projects that maybe not as rigorous as we would do in a true lab setting, but some things that you can look at doing at home with kind of household materials. So can we look at viscosity with cornstarch and water? Can we look at the different densities of fluids and how they would flow next to each other with things you can find in your house and some like experiment you can do on your own? I know I'm teaching a graduate course this semester, and I went through and filmed a little video of how to put together a little demonstration unit with some pieces of cardboard and thumbtacks that that kind of showed one of my topics that I wanted to discuss in class. And so I went through and kind of showed that, and I got feedback. A number of students actually did create it kind of along with the video, and kind of had that as a piece of their learning. And so it's difficult. We are in a hybrid model right now at U of R, which means that all classes have to be able to be taken fully online, but there is some in-person interaction going on. And so there are courses where we are actually doing in-person kind of things where you go in and you can conduct small scale experiments. We disinfect and clean everything between the students and between people, but it's not gone away entirely. We're just trying to reimagine how we can do it. Small group projects are generally a little more difficult, so we're doing kind of like individual by individual. And we, again, film them. So just in case, you can always watch a video later to kind of remember your, remember what happened if you're writing a report or something on it. So it's difficult, but we're kind of working with it along with everybody else. We're talking with colleagues within different departments. So between mechanical engineering, chemical, biomedical, the deans are involved. One of our faculty members is actually a dean of the college. And so he's on a special committee, and he's actually gone out to college-wide groups that are discussing this. So between upstate New York colleges like Cornell, Ithaca College, University of Rochester, RIT, things like that. I have colleagues at RIT who I know, and I've talked to them about what they're doing and how they're approaching this whole kind of thing. And so everybody's kind of, if I had to put it in one word, everybody's in it together. We're trying to make it as best we can. But that doesn't mean that it's going to be just the same way as if it was fully in person going forward. Ideally, next fall, we would be back to in-person, fully kind of teaching.
Yeah. And I will say one of the, just being like obviously not a professor, but an observer, like when March happened and all of us like started trying to do online, I thought it was so, there were some professors, of course, like we have young professors like Ethan Burnham Fay, and then we also have really old professors, and they were so dedicated to like learning how to use technology they've never used and understanding digital classrooms and taking workshops through our like the Warner School of Education to like learn about online teaching. Like I don't think any of the ME professors thought that it was acceptable to have a decrease in quality of education just because we can't teach the same way. So the dedication to the like quality of the education that's happening, even if it's not as hands-on, is just remarkable to me as a staff member who just watched, went to the staff meetings or like the faculty meetings and listened to all of the professors trying to change their courses, like how it was like a matter of life or death. Like it wasn't like, oh, that sucks, we can't have lecture anymore. Like it was long, extended conversations between so many people on how to make the most of every single course. So there's a lot of people working behind the scenes to do as much as we possibly can to like maintain the integrity of the engineering program, even in the strange world we're living in at the moment. Let's see what we have I think we might have some quickies. How many students on average double major? It varies by cohort. I would say if you are passionate about two subjects, absolutely it can happen. There aren't a lot of like times where I meet with students where I say double majoring is just not possible for you if they come to me early enough. So that is, if you're really interested, hit the ground running, know that you're going to be trying to take like 2 sets of coursework in your 4 years or possibly 5, just plan ahead. But again, it really does change. I can think of like lots of kids off the top of my head who are in double majors. So like we have ECE and MECE crossovers, chemistry and MECE crossovers, physics. Again, I think I mentioned that one is like particularly popular, in math as well. So there's not really a set average number. It's on a very much like individualized basis. And then we also have a question. Do you have something to add, Ethan?
Yeah, I was just going to say it's very common in minor and other kind of fields as well. And just the one of the most extreme case of dual majoring was a student a number of years ago, but he dual majored in performance violin and mechanical engineering. He graduated in 4 years. I don't think he slept for 4 years, but he did it. And he graduated, very good student, very smart guy. And it's really, as Sarah said, you just got to come in and hit the ground running and have a kind of a plan that's what you really want to do and be willing to adapt to those kind of challenges.
Yeah, he's like infamous. I still look at there's one other student currently that's trying to do a dual with Eastman School of Music and Mechanical Engineering, and we defer to that student who did the performance violin to sort of see how he managed to do it. But it's possible, and then you'll be infamous forever as a double Eastman engineer, which is just so intense and amazing. So here's another question about our alumni network in the like the industry, which is definitely more of an Ethan question.
So there's people from U of R everywhere. I will say this, and I am biased. I am a mechanical engineer, and so I think mechanical engineering is great. If you go into other engineerings, that's fine too. But I'm a mechanical engineer, so that's my favorite. And part of that goes along with that is mechanical engineering is, in my opinion, the most broad of all the engineering topics or disciplines you can get into. We have many students who go into biomedical graduate degrees, for example, go into aerospace graduate degrees. We don't really offer aerospace here directly at U of R in our department, but you'll cover a smattering of everything that will allow you to go into various disparate fields. We've had students go to SpaceX, go to Apple, go to Lockheed Martin, go to small optics companies in the local area, go to Boston, go to NASA down in Florida, go to Caterpillar, the giant like kind of forklift and front end loader and bucket loader manufacturer. I know a close friend of mine worked with them. Now he works for sales for somebody else. Going into wind turbine generation, power generation, robotics industries. It runs the gamut. And so that's where I kind of said for internships, when you go through the kind of the courses, you'll learn something that sparks your interest, or you want to apply it to renewable energy or to robotics or to space exploration. And that will dictate kind of where you go. My area that I found when I was at U of R was between mechanical engineering and optics. So that's kind of the courses I teach in the area I work in right now. But that's kind of, again, a unique area that I found my niche that I really enjoy. And so that's what I kind of do. And there's lots of opportunities there. The alumni network is pretty good. As Sarah said, she gets updates from people and can reach out to people to say, hey, look, do you have any job openings? Are you looking for co-ops? And so the Rochester Alumni Network is pretty darn good in my opinion, and has been nice for that.
Yeah. And there's definitely something to be said for, I think, the University of Rochester's community type feel. Our campus is not small, but like it's small enough that you know where to go and it feels like a home, but not ever big enough where you're like constantly like high school where you're saying hi to everybody you pass. So there's a lot of events on campus that bring people from the community or alumni back. Like I know my junior year, it was Meliora weekend, which is like alumni weekend. And I just ran into like an alumni. He asked me where to go, and then he ended up offering me a job at the Anchorage Daily News in Alaska. I was like, what? So I think there's like weird, like, again, life is just strange. And I think when you are living in a community where people are very friendly and very passionate, which is what happens at U of R, everybody wants to talk about what they're doing and they want to find interesting, passionate people, and they come back to campus looking for those people. So I think the community aspect of U of R really scaffolds the alumni network and creates like the situation to just end up meeting someone on the side of the street and then they offer you a job. It's strange, but it happens and it's beautiful. And it's something that I think is very unique to our school, because I have friends who went to like huge stake schools and I don't think they never had like those same type of opportunities. So I think the University of Rochester size, like it fits a nice little niche in size. Do we have any other like final, we got one more maybe, final questions?
Be a hand up, I think.
A hand? A hand? What does that mean? What do I do? Do I click something?
I don't know. I don't know
What
how
do I do?
They're not going to be able to communicate with us. If they raise a hand, they can add a question into the Q&A.
We can also answer, like, in the last few minutes, like Ethan and I were both U of R students, and also we've all lived here in Rochester for years, Zach included. So if you just have like a random question about what Rochester is like, how's the weather? We can do that too. It snowed here yesterday. I was really excited.
Sansa was really excited to see the snow, Sarah.
Sansa, Ethan's dogs.
I have a 150-pound Newfoundland St. Bernard that comes to class with me at least once a semester. And she loves the snow. She slobbers over everybody. But it just started snowing here off and on. We don't have any on the ground, but she loves that.
Oh, a quick question came in on how big our class is. Depends on the class. Our largest engineering courses are capped at 130. However, we never make it to 130. Our 130 cap class historically runs around 95 students, and that's ME 104, Engineering of Bridges. So there's a lot of kids who aren't even MEs in that course. But the higher up you get in the curriculum, the smaller your courses are going to get. So I think for a lot of like recitations and workshops, you're looking at like 10 to 15 people. So it's really dependent on the course, but I know like the biggest course I ever took in my undergrad was about 100, which and my smallest course I ever took was me and 2 other people and the professor in a closet in Rush Rees. So you really will get like a full range.
Yeah, there's usually that first semester, the largest courses you'll take aren't actually MECI courses. They're like the general chemistry and general math and stuff like that. Those will be big, but you'll usually have the MECI course as well, the engineering bridges. And then that writing course you take mine was 15 people, I think, when I took it with the instructor. And mine was on monsters. It was like Dracula and werewolves and stuff like that. And I had friends who were in ones that were like comic book heroes and stuff like that. So they were talking about like Thor and Iron Man in their writing course and stuff. So there's a smattering there that you kind of get.
Oh, we got one more.
Yeah, academic support. So Sarah can answer this really well, but just from my point of view, we have the best course of action, regardless of where you go, is go to TA and professor office hours. Everybody says that and nobody does it. It's really, really worth your while to do that. Something that you may take an hour to kind of think through and understand. I will sit with a student for 5 minutes and I can explain it multiple ways and maybe it makes sense one way and doesn't make sense another way, but we can kind of talk through it and make sure we all are on the same page. There is Tau Beta Pi is the Engineering Honor Society, and they offer for every single engineering course that we offer, there's at least one student who has to sign up to be a study guide for that course. And so that's school-wide. So every kind of department has this. So there's at least one person there from an outside perspective that can help you. And then again, too, if you're part of Baja or other clubs, you'll know some upperclassmen who can maybe think back and say, you know what, I remember that was being really difficult. This is how I understood it or how I got through that, which can kind of be a nice kind of part there.
Yeah, and then every few weeks review the grades for almost all of my students on midterms. So if I notice that a student's struggling in a course, I send them emails and I start talking to them about what their opportunities are. And if students historically struggle in courses, they get special counselors appointed to them. We have the Center for Teaching and Excellence in Learning, which is an entire center dedicated to tutoring one-on-one. Every single semester, the College Advising Center sends out an academic resources handbooks that show you all of those, not just CETO and not just what we have for engineers, but literally it's like a 20-page handbook that goes through all of the every single tutoring opportunity and office hours, drop-in type things that are just open to students. So I think one of the biggest things is that it's very one-on-one. Someone is looking at your grades. It might not be your parents. It's me. And then I'm going to send you an email. So we care, I guess, is the big thing, is that someone's tracking your grades. We want you guys to succeed. We want you to graduate in 4 years and finish the program and do well in those courses. So someone will be there, me in the background, keeping track of you all 4 years. Big Brother style. That's creepy. Never mind. Anything else, guys?
Campus is safe. There's blue lights like most campuses have. We're a pretty safe campus. We get updates occasionally of any incidents that are even in the area. And usually that's kind of we're right by a park and we're right by some busy intersections across the river. So campus itself is very safe. But if it's within a certain distance of campus, they always let us know.
Yeah. It's also, I live off campus. I lived off campus as a student and then now as an adult. But I live in essentially a student housing neighborhood. A lot of my neighbors are undergrads or graduate level students. And there's blue light phones almost the entire way to my house. So even though I'm not actually living on campus, they're still keeping track of they know that students are living in these neighborhoods surrounding campus and there is a public safety presence there. So I walk at night sometimes, with just me and a girlfriend from campus back to our house. And we never have problems and we don't really worry. So I think obviously always use your noggin. We're still in a city. I grew up in rural Pennsylvania. So I'm a little overwhelmed sometimes by all the honking horns and lights and everything, but use your noggin. And for the most part, most people feel pretty safe on campus, I think.
I just bought a house here, and I'm a mile or something from campus. I bike in most of the time, so it's like a 10-minute bike ride for me. I can walk in 15, 20 minutes, and I don't feel unsafe. As Sarah said, you got to be a little bit smart about it, but it's a pretty safe area. And I don't know if anybody has anything else, but I just wanted to add one more thing, is that even in these kind of times, usually when we're in person, we do a lot of fun activities as a department. So we do things like we do a fall picnic that we're now doing away with, I think, because it was too cold and raining when we've done it the past few years. We didn't do it this semester, obviously. But we do things like that. We have an annual faculty roast every spring, which is where you've had us professors for 4 years, and we've had you students for 4 years. So there's some playful ribbing back and forth about certain. So I'll throw Professor Funkenbush under the bus. When I was an undergraduate, he would always gesture wildly and walk about wildly in the lecture hall, and always would knock over a chair without fail every lecture. So we made jokes about that. Things like that. So it's a really inclusive department. It feels more of like a community than anything. I'm playing Among Us for the first time tomorrow night with the ASME group from mechanical engineering. I've never played. I'm going to get beat pretty badly, I expect, but that's the type of thing we do on kind of a semi-regular basis, is to try and make it so it's not always academics. There's some kind of social aspect to it too, which is another real strong suit to the department, I feel like.
Ethan, we were literally, Jill is the head administrator for the department. We're talking about how we should have like a faculty Among Us event before Thanksgiving, just
They're
to
doing
like,
it for
have some
ASME
fun.
tomorrow night, so I'm going to play so I can test the
faculty
waters
and
there.
student Among Us competition.
All right, guys, I'm gonna step in here at the end of our time this afternoon, or early afternoon or evening, depending on where you are around the country or the world. I want to thank all of you as prospective students for joining us, and hopefully you were able to get all of your questions answered. I'm glad that we had a pretty active Q&A box there. I want to thank both of our panelists from the mechanical engineering department for donating their time and their knowledge, and certainly their sense of humors to again, I put my email address in the chat box, and I know Sarah shared contact information towards the beginning of her presentation. Please feel free to get in touch with any of us if you have any questions. We're all happy to help in any way that we can, and if we can't help, we know plenty of people who can. All questions can get answered across the board. So please stay in touch. Thank you for joining us. I hope everyone stays safe and healthy. Take care and have a great rest of your day.